All right, this is example 3 in 1.1 for Math 20-1, and it's a bit of a word problem. It's one of those things that it's easy to misread, honestly. It says the top 6 rows of a display. Students often read that as there are 6 rows and that's it. We don't actually know that. But much like stacking the boxes themselves, it's actually much better if we make the first term the bottom. So the first term is going to be the bottom of my, pyramid. And then of course the last term, we don't know what it is yet, but that's going to be, all the way at the end there. So it says that there are 16 boxes in the third row from the bottom. So that's the first term, second term, third term. The third term is 16. Then we have 4, 5, 6, 7, 8. Ooh, just enough. And it tells us that the 8th row contains 6 boxes. All right, and then it says for A, how many boxes are in the bottom row, which is term 1, essentially. And then really we're going to do B before we do A, and that's okay. To do this, then, what we're going to look at is basically, how do I go from 16 to 6 in an arithmetic sequence? And if I'm going to go from term 3 to term 8, then what's going to happen is for each of these red arrows that I'm drawing, we are going to add the common difference once. And so on all the way. Now what that lets me say is that 16 plus 5 times whatever the common difference is gives me that number, which is 6. Now a lot of students get caught up in thinking that the common difference always has to be positive. It doesn't. We can add a negative number just as easily as we can add a positive number. And that's what happens in this question, because in order to solve for D, what I'm going to do is I'm going to subtract 16s on both sides. I get that 5D is equal to negative 10. So when I divide by 5, I get that D is equal to negative 2. Now, I always like making sure that that works. If D is equal to negative 2, then 16 plus negative 2 is 14, then 12, then 10, then 8, then 6, and then we would have 4 and 2, and then eventually 0. Now, what's really important is to move forward in my arithmetic sequence, I added the common difference, which means to do the opposite, I subtract the common difference. So if the third row has 16, the second row has 18. If the second row has 18, then the first or the bottom row has 20. So the answer for part A is that there are 20 boxes in that bottom row. Keep in mind that the bottom row was our first term. And that's really important because now we can say, okay, term 1 is 20. My common difference is negative 2. And therefore, what we can say is that Tn is equal to 20 plus n minus 1 times the common difference, which is negative 2. So Tn is equal to 20 minus 2n plus 2. So the nth row from the bottom will contain 22 minus 2n boxes. And I always encourage students check if you've done it correctly. What happens when I put 3 in for n? I get 22 minus 2 times 3, 2 times 3 is 6. 22 minus 6 gives me that 16 number. So this general term will tell me exactly how many different boxes are in different rows. For C, it wants to know what is the number of rows of boxes in his display. Lots of different ways of doing this. Honestly, now that I've done kind of all the hard work here, I would just carry my sequence forward. So in the 8th row from the bottom, there's 6 boxes. Then we would have 4, then we would have 2, and then we would have 0. Now, mathematically, the 0 belongs there. But are you really putting boxes on a pyramid if you're putting 0 boxes? I would argue no. So mathematically, this is a part of the sequence, but based on the question, I wouldn't include that. So this is the 9th row from the bottom, the 10th row from the bottom. Therefore, for part C, if I keep the page on the right one, part C is going to say, oh man, I'm struggling today. C, we'll get there. There are 10 rows. And that's just because term 10 is 2, term 11 is 0. You can't have, you can have 0 boxes in a row, but it's not really a row at that point. It's just an empty space in your store.